Bismillahirrahmanirrahim. Well, this is the chapter about files, input and output. This is a very interesting and really enjoyable chapter where we learn how to use files, to store information in files, to save them, and then to read the information from files. Now, this is the main thing that is going to be the focus of this video. And in Java, they are called streams because the data is flowing from one part to another. So when the data is going inside the program, we call this is an input stream. If it goes outside of the program, we put it output stream. So it's all about streams, and we will see in some of the name of the classes are having that stream. So this is where it comes from. And we have these input streams that we've been using. Remember this scanner? We've been using that a lot to input something from it, and system.out to output something to the screen. So we would using the keyboard by using system.in, but we will replace that to be able to use a file, to read from a file, or to write into a file. But to write into a file, we're not going to be using system.out. We need to use other classes. We'll get to that. But we need to just to know that there are two types of files. There are some textual files and binary files. Well, just to summarize the difference between the two, the text file, if you click on it, you open it, you'll be able to read it. And a binary file is not going to be able to be read. So that's the difference between the two. But okay, what's the advantage? The advantage? Well, text files are easily readable, basically, but binary files are more close to the machine, so the information is going to be faster. So if you have a lot of information to store, it's kind of makes more sense to make it binary, to save it in a binary file, because it will be faster to process, and that's the main idea. So yeah, so let's just postpone this discussion for later on. But you know the two types of streams that are going to be with binary, those others are going to be with text. And yeah, so how to do these input and output operations? So the main thing is that we need to import something. The stars, you can use star, that means it will import all the classes, as you may already know. And yeah, Control E to have this here, there. So yeah, we import the classes, and then we get to the class. If you don't know what are the classes, you can import everything like this with the star, but actually we will know the classes actually, and then we will be doing that. And then we'll need to open the stream, to use it to read, write, or do both. But generally, if you read, you're not going to be not writing, but there's some specific classes that will allow you to do both. But now what we will be working on is either you read, you open a file, you read, and then you close the file, and you open, you write, and you close. So that's the main thing, how this is going to be happening. So how to open, and we need to use some specific classes. So if you'd like to output into a file, to save some information to a file, these are the classes that need to be used. So print writer, and then file output stream. Now there's another way how to do that. So if you'd like to read, is the buffered reader and then the file reader. And yeah, so these are we need to use both of them actually. The pair, the 2 by 2 to be used together. So now let's get into that. I would like to show you how it is going to be used. But before that, this is talk about the file names. This is the name of the file. Usually we use this .txt just to be able to see it in Windows, or generally any operating system that associate these extensions to an application. So basically you can use anything you want, but as it's any suffix, it's okay. doesn't have any difference for Java. It's just like a name of a file. But for the operating system, it will be easier for the operating system to know what kind of application can be opened with that file. So that's why you can name it .txt or .doc for Word or whatever for your word processor. And anyways, what you need to know is that there is a file name. This is the name of the file that is on the hard disk. And then there's this the file, the name that you're going to be, the string that's going to be used to open that file. Let's get into that. That's why I wanted to get into it, so you can see actually how it is going to be used. Now, this print writer is in the java.io, and we will use file output stream, both of them together. Now we're going to be writing something in the file. And because working with streams or files can lead to some exceptions, and there's a file not found exception that has to be also dealt with. Because if you try to, for example, save a file into a disk, but the disk is full, there's no way for you to do that, so you cannot be able, you won't be able to create a new file because the disk is full. Then this is going to be an exception. It's going to be erased. Or if it's the opposite, you're trying to read a file from a disk, and then the file that you mentioned, the name does not exist, or maybe you just misspelled something, or maybe the path, the way it is stored in, you did not mention it properly, so it will raise the file not found exception. So we need to work with those exceptions. And I'd like to show you how this works. Now, this is how it works. You declare an object of this type, print writer, that you call output stream, or call it whatever you want. This is a stream that is going to be saving things in a file. So you're going to call this with the new print writer. This is the constructor. But then notice that inside this constructor, we create a new object from a new file output stream. So this is a new object. And in that new object, we call the constructor of that new object file output stream with the name of the file name that we would like to, with the name of the file that we would like to store the information in it, to write into it. So that's it. So actually, what this will do, this is going to make sure that it prepares this variable, this object, to have a stream, to be able to have access to a file, to write inside of it, and the name of that file is out.txt. You can do that in two ways if you want. You can do that in two steps. The first step is that you create an object of file output stream, and you save it somewhere, and then you put it as an argument for the print writer. But you have to use both classes, the print writer and the file output stream, both of them. And you can do that in two steps or one step, whatever is convenient to you. But this is faster. And that's how it just creates the output stream to allow you to store some information to a file. So now, as we mentioned, we need to catch some exceptions. And the exception is that we might not find the file. So file not found exception is something that has to be managed. We'll see how we can put that in the code. Basically, in whatever you're going to be doing, when you open a file, you put the this open a file and closing a file inside the try catch. So we mentioned before that whatever you need to do is that you, where is it? Here, we open the stream. That's what we did. We later on we will see how we can do some writing because we opened an output stream, so we'll do some writing. And then when we are done, we need to close the stream. So it's important to close the stream because if we don't close it, things might not be saved. And that's what this is discussing. Because also you need to if you open a file for writing, and there's an output stream that is connected to it, you cannot open it from another object of input stream because it's already opened by one of the streams, and this is you cannot open it unless you close it first. And if you close, then you can open it again to read from it or to write to it again, and so on. All right, and this is what I was mentioning, is that when you save things in the output streams, not every time you save something that you type the command to the instruction to store something inside the file, it's not going to go immediately directly to the hard disk. Why? Because the hard disk is kind of slow. So if every time it goes, it has to go to the hard disk and the program has to wait for it to go to the hard disk, it will take a lot of time. It will slow down the computer and slow down the application. So that's why they are that is called buffered. Buffered basically just like some kind of memory. So every time, let's say I'm going to save inside the file 1, 2, and 3. If I type the command to save it inside the file with 1 and then 2 and then 3, it's not after each one of these instructions that is going to go to the file. It's going to wait until it completes a set of it saves them into some kind of temporary location that is called the buffer. Once it have enough data, it just flushed it. That's what the flush means. It's send it to the file. So the data is going to be written all at once, not 1, then 2, then 3. So we'll save 1, 2, and 3 next to each other. I mean, after one after the other, not sending to one and then okay, go back to the program and then get okay, what's the other information too? Okay, go send it again to the file. So it gets all the information that need to be saved into the file, and then it saves them in a bunch, in a group, in a buffer. That's how that's the name for it. And this is more efficient because physical writes are very slow. The slowest thing in your computer is your storage. So that's why we would like to minimize working with it. So that's why this is called buffered. And basically, when you close your stream, your file, it automatically calls the flush. So if you haven't saved, if you close, then it will save. And if you don't close, you might not see the data inside the file. This is an example. We have, this is just print writer. Now notice that this is put outside because we put the try catch here. We try to open the file into, by doing this. The declaration has been kept outside. Why? Because if I catch or I would like to close, I can do something outside. But I can basically, because of this example, I can just take it and leave it inside. It's not a big deal. And then if there's a problem, I'll catch this file not found exception, and then I can display some message and stop the program, for example, or do something else. But that's how I would use the try catch along with this output stream or input streams. Basically, you can also catch, instead of this explicit exception, you can use IO exception, which is the superclass of all these find not found exceptions and other type of input-output exceptions, and it will catch all the type of input-output exceptions. Anyways, these are called checked exceptions. Actually, checked exceptions, that means they must be caught or declared in a throw clause. That means either you catch them or you throw that exception. But not like some exceptions are unchecked exceptions, like no such element exception, input mismatch, illegal state exception. These are unchecked, which means they are not required to be caught or declared into a throw. If you don't have to. But with these type of exceptions, you have to either catch them, you have to try catch, or you make it the method to throw the exception that you're not catching yourself. If you remember this discussion from last week when we talked about the exceptions. Now, there's a situation where you'd like to save the file, something inside of a file, and keep what was inside, because every time you open a file, let's say if I do something like this, I open the file, this out.txt, and then I save something inside of it. And then later on, I just close it and then open it again and to write. If I open it again to write, actually it will erase everything that was in it. And it will put the new information inside. That's the problem with that's the default behavior. It's not a problem. That's how it is programmed to work. Every time you open a stream, like for output stream, it's going to erase. Every time you open an output stream, it will erase the file if it already exists. If it doesn't exist, it will create the file, and it will be empty, of course. So at the end, after this line, if the file exists, it will empty it. If the file does not exist, it will create it, if it can, of course, if there's enough space in the storage. So that's the idea. And but there's some situations where you'd like to keep whatever, you would like to open it to write, but you'd like to keep what was before. And this is called appending a file. So if you'd like to append a file, it's very easy. It's the same statement, except that this constructor now, there's another constructor, file output stream, that takes two arguments. One that is the text, the file name, the string, and the other one is a Boolean value. If it's true, that means you'd like to save what was before. Don't erase the information. So this is how you can append a file. That means you can keep the information that was there before, and every time you write inside the file, it will just write at the end of the file and continue where the last data was added. And then if I'd like to put something inside, well, I need to use those methods, print or println or printf, if I'd like to do some kind. So it's just like output stream name dot print, and then you put the information, or println, you put the information between parentheses, and then it will be saved. That's the information that is going to be saved inside the file. And you close at the end. Don't forget to close. It's very important to always close. Where polite, you open something, you close it. That's it. You open the door, you close the door. And now that's the same thing. You open a stream, you close a stream. Let's make it like some kind of habit. And why bother to close a file? Because if you can, if the program stops, it will close automatically for you. But just make sure that your program always stops normally, because if it doesn't, it will not do that for you. So, and make sure also to always close, so you avoid that if you open the file again for within the same program to another place of the program to add something to it, but then did not close it, you won't be able to. So it's important that you open a stream, you close. You finished, you close. That's the thing. And if you would like to read from a file, then you use the scanner. The scanner, we use it for reading from the keyboard. How can we use it to read from a file? Well, instead of having the system.in inside here when we see the new scanner that we used to put in system.in, well, this is what we're going to do. New file input stream. Now remember, we were doing file output stream when we were writing inside the file. Now we'd like to read from a file, we use file input stream. And then you give the file name, same idea. And we can use the next int, next line, and things like that. Now let's have a look at this code. So this is going just to display something. The scanner, that means it's going to read, and then I'm going to open the file called morestuff.txt. And then put that into a try-catch, so if I cannot find the file, it will just raise some exception. And then once I have that file is opened, then I'm going to, this is input stream, this is the input stream, this is scanner, this is the object of scanner. So the input stream.next int, next int, next int, because I'm reading 3 ints, and I know that the file have 3 ints. Okay, what if the file does not have three ints? Well, you'll have an exception. Same thing like if you type like a string while the next int is expected from you. That's going to raise an exception. So that's the same idea. So that's how you're going to read the 3 numbers. Notice that these numbers are not read each one on the line. They're all 3 in the same line. Then have this next line to go back to the new line. And then I can read the next line. And that's mainly, after that, these are just to display what was read. And that's, for example, if this is the content of the file, you get something like this, 1, 2, 3, 4, and then that's go back to the line, then 8 my shorts, whatever. So that's the main thing. So just sorry, this is the file. So if the file is something like this, basically the file is going to, yeah, I did not pay attention to this, but this is, if this is the file, I'm running this code, the output is going to be, let's have a look. It's going to be 3 ints, so I'm going to read this one, then this one, then this one, and then after that, next line. So it will just read from here until the end of the line, but there's nothing else. And am I saving this somewhere? No, I'm just reading it. I'm not saving it somewhere. So that means this is not going to be saved. And then I have read next line. It's going to read this whole line and save it inside this variable called line. So that means if I display these 3 numbers, I'm going to see 1, 2, and 3, and this Itmai Schwartz. So that's the output. So 1, 2, and 3, and then the line from is Itmai Schwartz. So that's how it works. And there's a way, what if, okay, how do you know that you have reached the, when you read from a file, how do you know that you have reached the end of the file? There's no need for you to read. There's nothing else for you to read. Or there's something that is having this has next int or has next line, or this is like, this is a method inside the scanner that is going to return a boolean. Either it's true or false. It's true if there's something else to read, and if not, it's going to be false. So that's, these methods are going to be returning a boolean, either it's true or false, and based on if there's some information that is available to be read or not. And let's have a look at this code. You see we have now 2 streams, one that is an input stream, a scanner, and the other one is an output stream, a print writer. And then I'm just going to open this original in the scanner. So I'm going to read from original, and I'm going to write into numbered.txt. So I'm opening 2 streams at the same time. So I'm going to work with them, and then if there's any problem opening one of them, is going to be caught in this find found exception and stop the program. But if they're all right, we just keep going. Okay, we have string, line, count 0, and then we have here, while there is a line to read, I'm going to take the line, put it inside this variable, count, increment it, and then I'm going to, in the output stream, in the file that I'm saving, I'm going to put the number, this is line number 1, and then a space and the line that was read. And this is going to repeat for each line that is inside the input file, input stream. So I'm going to read, the result of that is I'm going to read each line from the original, and I will add into the, what is what's called numbered file, the file number.txt. I will have exactly the same file, but the same content, but before that line, I'm having the number of lines. So line 1, line 2, line 3, line 4, and so on. And when I'm done, I just close the streams, and that's it. So if the file is like this, if the original is this one, then the number is going to be exactly the same, but now with 1, 2, 3, 4, 5, 6. So that's the idea. And notice that what we use is the scanner to read. And there's another type of class to use to read, is that reading using the buffered reader. Now the buffered reader is the same as a class, a stream class that can be used to read from a file, and it's, instead of using the scanner, you use buffered reader, and it has the method read and read line. Well, the difference between the two is simple. There's no big deal between the two. The buffered reader has only read and read line, but the scanner has more details. You have next int, next double, next float. It can read different data types. But if you don't need to read different data types, you're just working with text, for example, then the buffered reader is just enough for you. But if you'd like to actually read some int and then read some doubles, etc., then the scanner is your best choice. If you can still read with the buffered reader the int, etc., but you have to read the ints and then convert them to from string to int, because whatever you read with the buffered reader is always a string. So that's the idea, and it's going to be opened the same way, except that you can use file input stream, or you can also use this file reader. That's another class that does that. Yeah, and that's how you can, I mean, read from a text file using this buffered reader. Something to notice though is that read is going to read only one character, and the read line, this I should be lowercase like this. The read line is used to read the whole line, basically the string. So when you do something like this, you have to actually convert it to a char, or wait for it to be converted automatically, because a char, as you remember, is a primitive data type, and internally they're stored as numbers. So the value actually of this is the number, that is the number according to ASCII table, if you remember talking about that. So if you don't remember, just Google ASCII table, and then it's this is how ASCII is double I, ASCII. The ASCII table is a table that shows you every character has a number associated to it. And when you do the read, it will give you just the number. If you'd like to convert it to a char, you can do it. And if you store the number directly, it will automatically convert to a char. But the point here is that we'd like you to realize that read is actually just a number that is going to be considered to be a char. And that's an example of how to read using that, the buffered reader. And you can read just one line, like input stream you read, and then once you read that, you can display it, for example, on the screen by doing something like this system.out.print line. So this is the first line that was read, and then this is the second line. And because there's no loop, it just display two lines in here. They did not put it in a loop. You can have this kind of exceptions. Now, you see, these are catching two types of exceptions: the specific one and the more general one. The file not found exception, it's just, okay, so the file was not found, you'll display that message. But if something else happens, then you have this IO exception that is caught. What kind of other things that might happen? Well, if we go up, we see this like I thought there was some more detailed exceptions that were mentioned here. I don't remember exactly what kind of exceptions that we need to be talking about, a specific one, because this file not found exception is a subclass of IO exception. So if this specific exception is caught, then it's going to be executed, and this is not going to be caught because this is specific. But if you remove this one, it's okay, because this is going to be caught by any exception. File not found exception or any other IO exception is going to be caught here. All right. The read line is actually, that's why we need to catch the IO exception. The read line is the one that throws the IO exception, while the file not found exception is thrown by when you try to open the file. When you open the stream, this is the file not found exception that can be thrown. So basically, just let's go back here just to make it clear. This can throw the file not found exception, and this can throw the IO exception. So that's why both of them have to be caught. Or if you don't care about giving a specific message, which is not actually wise, but just to give you an idea that if you remove this here, you move this catch, and you keep only this one, that will be enough. It's okay, because file not found exception is a subclass of IO exception. So this can be this can catch all the type of exceptions. And if you'd like to read the numbers, well, then you have to read them as string and then convert them using the integer.parseInt or the double.parseDouble and something like that. And there's also a class that is interesting that it's not out of the scope of this discussion, but you can Google that, string tokenizer, that allows you to split some a string into different parts based on spaces or You can even customize how do you split the string. But anyways, you can still use the buffered reader to read numbers, for example, but you have to read them as text and then convert them. And the method readLine returns null when it tries to read beyond the end of the file. So if the file is finished, you read everything, and then you try to read again, this is going to return null. The read line is going to return null. So if it returns null, that means nothing is available to read. You finished all the file, you reached the end of the file. And the read is going to return -1. -1, it means like the end of the file. So that's how we can know. While the scanner has the has next line, has next, or just has next int. So with these, you have to test basically if it's null or not. And okay, let's have a look at this code. Now we have here the scanner that reads from the keyboard. Let me just remove that. Okay, and then so we can read something from the keyboard. This is just to read the file name from the keyboard, and this file name that is going to be used, we use the buffered reader to open it. So this is the name of the file. I don't know what the file is because the user is going to tell us, okay, what's the name of the file? And then we try to read the line. Actually, it should have been wise if I just put a test. If the line is different from null, then that means, okay, that means I was able to read something, and I can display it. If not, I'm going to display null. And then I close the string. And we have the to catch of file not found exception, which is going to catch this type of exception that's going to be done by buffered reader and this line actually, trying to open the file. And this IO exception is going to be catching whatever this read line is doing. And basically this is how we test if you've reached the end of the line or not, as I was mentioning just before. So you try to read, and then if this is different than null, that means, okay, what I read is actually an information. I have not reached the end of the line, the end of the file yet, so I can do something. And then you read again, and that's how you can actually do why it might have been better in this case. But anyways, you get the point. Now, if you mention a file name, what we've been using so far is just the name of the file. Let me just go back to, like, for example, something like this. I'm just using the name of the file. So where should the file be if I'd like to read from a file by just giving the name? Well, it should be generally in the same, for us using it will be in the same folder when you have your project. But what if your file is not there? Your file is in drive C, for example, or drive D, or any other place, in a folder inside drive D or something like that. That's how you're going to be talking about the paths. Now these paths, if you have it's under, let's say, Linux or Unix, it's something like this type of, with this / or / for the Windows. Now if you'd like to store them like that, then inside, for example, if you're using this on the Windows, you have to, inside this double quotes, instead of just giving just the name of the file like this, you have to give the path with double backslash. Why? Because actually one backslash is like an escape character. Remember, if you use backslash and then double quotes or backslash single quote, it means something. And now double backslash is actually just one backslash. It is going to be converted to this. So you have to do it that way. All right. Now, talking about the binary files. The binary file, just if you remember the discussion between the text file and binary file. Text file, just textual. Whatever is saved, the files are saved inside of a text format. So you can, if you double click on it, you'll be able to read it. So inside the files, it's just a text. But binary files, inside is stored, the data is stored in the same format it is used in the computer memory, which is, it don't need to be converted to a string, so you can be able to see it if you double click on the file name to open it and see it. So that's the advantage of it. Why is it an advantage? Because it's faster. You don't have to convert and to put it inside the file and then to convert it back when you read it from the text to whatever needs to be done in the computer memory. So you're faster this way. And now remember, it doesn't look fast if you read one line or two lines, but if you read thousands of lines or millions of lines, then it will make a difference. It will take some time. So that's why these binary files can be interesting. So how can I work with binary files? It's obviously the same thing, except that different classes have to be used. Object output stream with the file output stream, we've been using that, and then object input stream with the file input stream. That's pretty much it. Not much of anything new, just if you change the type of class, then you're going to be working with binary files instead of textual files. And this is the same for this object input stream output object output stream. I'm just trying to show some code. For example, if you'd like to open this file like numbers.dat, I mean that this is like some kind of a I don't know, some kind of unified way to or standardized way that everyone, if it stores something that is in binary or that is not meant to be read or double clicked on to see it, you can use that or data, DATA. So it's okay, but it doesn't matter. This is just the name of a file again. You can name it numbers.txt, it doesn't matter, it will work as well. It will still be binary, and if you double click on it, you won't be able to see actually the values or the information that you stored in it. So let's get into that. So you have to object output stream, you create the object, and then new object output stream, and then you put this new file output stream, which is basically the same. This is exactly the same as what we used to do with the textual files, which makes sense because we're just using the same stream. This is just opening a file, but now the way we're dealing with it is with the binary file, binary data, which is needed to be having this kind of class. So that's how we use that. So file output stream basically can, instead of doing like this, I can do it in two steps like we did before. I can just do this first, give it a name, this the middleman, and then you put the middleman here. It's just basically the same if this is kind of too complex. We do two things. The first one is this. We initialize a new object from file output stream, which is this is what is happening and stored inside the middleman. And then this is going to be inside the parentheses of this parenthesis, which is inside this constructor of this object output stream. And that's what we're doing here. Object output stream. This is the middleman, which is this thing here. Alright, and then if you'd like to write inside of it, this is how you do. You use these methods. You have the methods write int or write double or write boolean, etc. You have many different methods that are going to be writing the information based on their data type. And then you need to be able to catch the IO exception. And yeah. And also note that each write method includes the modifier final because they cannot be redefined. They don't want you, if you would like to inherit this from this, you would like to extend this object output stream to have a subclass of it, and then to make a change to this write int to write double, you can't. So you will not be able to, because these with the final means you cannot override them. And of course, don't forget to close. You open, you do, you read, you write, and then you close. That's the main thing. And writing a character to a file, and yeah. So if you'd like to write char, there's some kind of small annoying property, as I said. It takes an int, not a char, because again, internally it's like a number. So if you'd like to take it as an int, if you'd like to save a char, you cannot just do this without this. It's not going to be, well, actually it will. It's going to convert automatically now. But you need to realize that this char is going to be converted to an int before it is going to be sent to this write char. Okay, that's basically the summary of all this. If you don't do it, it will be done automatically. This automatic conversion is going to happen. But you just need to know that this is happening. And when you read, just make sure that you read the right amount, the right data type, because if you're not reading the right data type, the information that you're going to put into your memory is going to be kind of messed up. So when you work with binary, it's kind of the advantage of you have this fast, but you have to be careful of you have to know exactly what you're reading, what's the data type of the information you're reading. And yes, opening a new input file. Basically, every time you have this input output. Basically, the same idea. Just this is an example on how you open a binary file to read from it instead of just writing. And instead of write int, you have read int, obviously, and that's pretty much it. And this is an example. Now, they opened an input stream, a binary file. We're opening this binary file to read from it, and then this is expecting to have all ints, so it just reads every int at a time. Notice that there's this infinite loop. Why is it an infinite loop? Because we don't know how many numbers we're going to be reading. So we are going to keep reading until there will be an exception when we can't read. What's the exception? End of file exception. EOF stands for end of file exception. That means you have reached the end of the file. So you're going to keep reading until you reach the end of the file where there's nothing else to read. This line is going to raise an exception, this exception, and then you're going to stop and you close. So that's the idea. And you have also the other exception to catch. This final exception that can be raised because of this statement, and IO exception can be raised because of this statement as well. You can maybe try to read something that cannot be read as an int, you mean. So just that's basically the idea behind that. So I hope this gives you like some kind of an idea. And the next thing we're going to see is the exercises that will allow you to practice those. So let's see those exercises in the next video, inshallah.